The construction of the SKIF Scientific Complex has been completed in Russia, a unique project that will allow our scientists to develop new materials for aviation, space,
nuclear energy, and other important fields. How was it built? Why is this an undeniable reason for pride? And what is the hidden purpose of SKIF? We'll talk about this, other achievements, and the new hero of the week after a brief summary of positive news. In Nizhny Novgorod, another Meteor 120R hydrofoil vessel has been launched. At the Nevsky Shipbuilding and Ship Repair Plant, another Project RSD-59 dry cargo vessel at the Nefteflo plant. Two Project MPKSL passenger vessels have been laid down. The first updated UAZ pickup with a 2-liter turbodiesel engine and domestically produced safety systems has rolled off the assembly line at the Ulyanovsk automobile plant. Production of 700-ton beams for the Moscow-St. Petersburg high-speed railway has started in the Moscow region. The Ermakovsky mining and processing plant has started operations in the Republic of Buryatia. A hot-dip galvanizing plant has opened in the Novosibirsk region. A greenhouse complex has opened in the Voronezh region. A livestock complex has opened in the Arkhangelsk region. Russian schoolchildren won 5 medals at the 9th International Economics Olympiad in China. On Tuesday, the largest modern Russian scientific mega-project, SKIF, was inaugurated in the Novosibirsk region. This is the country's first 4th-generation plus synchrotron radiation source. Simply put, a synchrotron is a powerful X-ray, which allows you to look inside any substance and study its structure down to the atomic level. That means to understand how to create new materials and technologies that were previously unavailable to us. Here's how it works. Electrons are generated in a linear accelerator. They are grouped into a beam, they receive initial acceleration and an energy of 200 million electron volts. Then this beam enters the ring booster, where it is accelerated to an operating energy of 3 billion electron volts, and it is sent to the main storage ring. There, as it passes through the magnetic field, it generates synchrotron radiation. Around the perimeter of the main ring, there are 7 experimental stations, each for its own type of research. For example, for studying ultra-small objects, or for researching the properties of materials under powerful explosions, pulsed shock loads, and high temperatures. The main difficulty in building SKIF was the incredibly high precision requirements, because even the slightest vibrations can affect the parameters of the synchrotron beam, the electron radiation, and distort the results of experiments. That's why a multi-layered foundation, 12 meters thick, was built under the complex. Additionally, multi-ton tables made of Karelian granite were manufactured for the optical equipment, and the storage ring rests on 112 perfectly, even supports each with an accuracy of 50 microns over a length of 3.8 meters. SKIF has begun construction. In 2020, they started and first faced problems caused by the pandemic, and then with foreigners refusing to supply some of the equipment. That's why dozens of Russian institutes had to mobilize all their efforts to develop their own equivalents, and industry had to get involved in their production. All these years, scientists, engineers, and builders worked under intense stress 24/7, but they managed to complete the task and finished building the complex. Now an important stage of commissioning and equipment setup lies ahead, and the first experiments will begin here in the coming weeks. This is something to congratulate all participants in the process on, as well as Russian science as a whole. After all, the project is important in another way as well. Today, there are about 50 synchrotrons operating in the world, 2 of which are in Russia. Ours were built in the 1970s and 1980s of the last century, and due to their age, they have long lagged behind their more modern foreign counterparts. That's why Russian scientists were forced to conduct research at foreign facilities, which was never easy. They had to submit a proposal detailing the research goals and go through a tough competitive selection. And after 2020, even that became impossible. Our researchers were expelled from the Large Hadron Collider project for political reasons, despite their significant contribution to its creation. They were also restricted in other areas. However, at that time, the Siberian circular photon source was already being built, and so top-class specialists were once again in demand at home. And not just them. Opened last week, SKIF allows us to quickly close the gap and move ahead. After all, it has record-breaking radiation brightness among sources of a comparable class, which gives biologists, chemists, materials, scientists, geologists, and other specialists the opportunity to conduct unique research. That means our facility is becoming a magnet for scientific talent. Now, the best minds from all over the world will come to us, not the other way around. And now our young scientists will have one more reason to work in Russia, instead of in foreign laboratories, where they are constantly discriminated against and have limited opportunities. In addition to SKIF, Russia has already launched or is creating other major scientific projects as well. For example, the PIK reactor in the Leningrad region, the Synchrotron 3-electron laser in the Moscow region, the INKIA project, the REEF project, nuclear medicine complexes, and others. That's how it should be in a country that doesn't just live for today, but builds its own future. A future where you want to live and create. We will follow the development of the project in future episodes. Next, other technological news. Specialists at the Progress Rocket and Space Center have completed the design of the Amur-LNG reusable medium-class launch vehicle.
At the moment, the launch pad for it is being developed at the Vostochny Cosmodrome. The first launch is scheduled for 2031.
Which is why the Progress Rocket and Space Center is expanding its production capacity and preparing to hire additional personnel. The Amur-LNG rocket will be the first Russian reusable methane-powered rocket, and it can be used up to 50 times. In the near future, hop tests of experimental prototypes are planned. At the same time, Russia has completed development work on the creation of a photolithography unit with design standards of 130 nanometers. As part of the work, 2 prototype excimer lasers, photomasks, test structures, and a measurement stand have been produced, and basic technological processes have also been refined. The 130 nanometer standard on 200 mm silicon wafers is the main working basis for the industry. It allows for meeting the key needs of automotive electronics, energy, industrial controllers, communications, and specialized systems. And most importantly, to replace foreign equipment and move on to developing equipment with 90 nanometer standards. In the Murmansk region, Rostekhnadzor has granted Rosatom permission to build the Kola-2 nuclear power plant with innovative VVERS reactors with a capacity of 600 megawatts. Their design includes elements of spectrum control and the possibility of participating in a closed nuclear fuel cycle, thanks to the use of uranium-plutonium fuel. In addition, the reactors meet modern requirements for power systems, including maneuverability requirements, which is especially important for regions with grid limitations. This is particularly relevant for the Kola Peninsula. Now, after receiving the permit, the builders are moving on to the initial work on site. Next, a preview and the rescue story.
Russian society has accumulated quite a few questions about some actions of the authorities. The official answers are often not very convincing, while unofficial versions smell like conspiracy theories, or are simply tailored to the tastes of a particular audience in pursuit of hype. An ordinary person gets dizzy from the abundance of versions and ambiguities. to keep from going crazy and doing something foolish, you need to remember just one thing. In high-level politics, there is a factor that has a powerful influence on all decisions. It's not exactly a secret. Mountains of books have been written about it and thousands of films have been made. It's not exactly shameful, but it's not customary to discuss it publicly. It's like dark matter. It permeates all spheres of human activity, but it stays out of sight. This is the interest of the intelligence services. How does it influence the most important decisions, and how do you keep from going crazy because of it? I talk about this in a special episode on the sponsor.ru channel on Super.
In St. Petersburg, an 11-year-old boy decided to swim at the beach on Krestovsky Island and got an electric shock in the water by a cable that had fallen from the pier. The child lost consciousness and began to drown. Eyewitnesses rushed to help him, but they were also being shocked, and no one could reach the victim. Only one man, using a log, was able to pull the boy to shore, but by then he was no longer breathing. None of those present knew how to help before the ambulance arrived. But, fortunately, at the sound of the screams, Mikhail Kharitonov, the deputy head of the faculty at the MCOM University, who was resting nearby, came running. He immediately began cardiopulmonary resuscitation. He performed 2 cycles of 30 compressions and 2 breaths. It was unsuccessful. Only on the 3rd cycle did the boy's heart start beating, and 2 minutes later he opened his eyes. Soon, the medics arrived. Now, the child's life is out of danger. An investigation into the incident is underway. We thank Mikhail for his heroic act and wish him success.